Hey, this is Nick, and this is a walkthrough tutorial of how to get started writing smart contracts with Ontology. So the tutorial is actually part of the Ontology Learning Center by Tower Builders, and you can find it at learn.towerbuilders.org. So basically, when you're writing a smart contract for Ontology, there are a couple of options. So you can either write it to compile on the Neo VM or the Wasm VM. For the Neo VM, you have the options to write it in C# or Python, and C++ for the Wasm VM. So as a part of this tutorial, we're going to be going over how to write your smart contracts in Python with the intention to compile them for the Neo VM. Ontology actually provides a web IDE platform for writing your smart contract. So for those who are familiar with web development, this is very similar to JS Fiddle for JavaScript, CSS, and HTML, except it's for writing smart contracts on Ontology, where you can actually write and compile your smart contracts and run and debug them all from within the browser. And this is really for getting you started without having to install any applications or having to worry about deploying to any of the test networks and requesting gas to do those deployments. So this makes it really easy to get up and running very quickly. So this tutorial actually walks you through with very detailed screenshots, but I'm going to actually go through a live demo here instead. So if you go to smartx.ont.io, this brings you to the SmartX platform, and there's a couple of options to log in. So here you can either create a wallet file and log in that way, or you can use your GitHub account, which I found to be the easiest. So if you click the GitHub icon, now I already have an account, so it's going to sign me in directly. But if you were to create a new account, let's go back to the tutorial here. You can see that it's going to ask you to authorize your GitHub account, so just click authorize and it should create your account for you. And so once you log in, it's going to give you your list of projects. So in this case, it's a new account, so we don't currently have any projects in here. And you can just click create project to make a new project here. There's a couple of options. You can use C# or Python, and they have a JavaScript option here, but it's not currently available. So let's just click on Python. You have a couple of templates here that you can choose to get you started. So in this case, we're going to choose Hello World, and we're just going to call this Hello. Okay, so now that we have our Hello World smart contract, let's kind of go over some of the basics. So when you're writing smart contracts, there's going to be some pre-built methods that you can import. So in this case, we have one that's just called log, so we're importing it here at the top. And in any smart contract, we're going to define a main function, and this is going to be the entry point into your smart contract anytime that you're going to be invoking it on the blockchain. And so typically it's going to have two arguments. One is going to be an operation, and one is going to be args. So args is just an array of inputs to any of the methods you're calling, and operation is the method name that you want to call. So in this case, we have a method called hello, and we indicate that by calling an operation equals hello. And in our arguments, we have a single element which we're going to pass into our hello method. And inside the hello method, we have this log method that we're using, and it's just going to be printing the message that you input into the console of the node that it's running on. But in this case, it's not running on a node, it's just running on the debugger in the web IDE. So you will see it pop up here. And lastly, anytime you see a return of true or false, this is indicating the result that is returned for someone invoking this smart contract via a transaction. So anytime you return true, that means that the invocation of the transaction has completed successfully. And if it returns false, it means that it did not execute successfully. Okay, so now we want to just go ahead and compile our smart contract. There's a couple of options here. So we have V1 and V2 of the smart contract compiler. So V1 of the smart contract compiler is based on NeoBOA, and so that's why it's prefixed here with BOA. And smart contract V2 is actually a newer version of this package, and any of the prefixes are going to be Ontology. So we're just going to update this to Ontology here. Okay, and so basically I don't want to go over all the details of this, but there are some additional methods and functionality as a part of the V2 contract, so I would suggest using that instead. And so once you're ready, you can click compile. It went ahead and it compiled our Python smart contract code into this AVM bytecode. This is the code that is going to be deployed and run on the blockchain. And so you can save that when you're ready to deploy it, but for now we're just going to go over how to debug it from within this web IDE. So when you compile it, it gives you a couple of details about your smart contract. The main entry point into the smart contract is the main method. It has one function called hello that takes an argument of message. The contract hash is actually the identifier of your contract. So when you deploy it onto the blockchain, this is what you're going to use in order to tell in a transaction that I'd like to invoke this specific contract. So now that we have our smart contract compiled, let's just go over to run. And this is where you can run your smart contract from within the web IDE. And we have our contract hash here, which is automatically populated from when we compiled. And we have a list of our functions. So in this case, we have hello. And it has one input argument. So you can define what the type of this input argument is going to be. And in this case, we're going to do string. And I'm just going to type in the message world. And we want to invoke this smart contract in the debugger. So we have a couple of options here at the bottom. The debug run button is going to actually execute this from within the browser. The pre-run and run options are meant to be used when you have this contract deployed on either a private net, which we'll go over in another video, or on a test net or the main net. So for now, we're just going to use this debug run function. And as you can see here on the left-hand side, we have our logs. And we can see here that it successfully called the log method and it printed out world, which was our input value. And here it showed that it was an invocation transaction which returned an integer 1, and that indicates that it returned true. So that means that the execution went through successfully. So let's kind of modify this contract a little bit just to give you a feel for what's going on here. So let's go ahead and add a new function to our smart contract. And we're just going to make this method called add. It's going to take a couple of arguments. We're going to make them test1 and test2. And we're going to have 0 and 1. And we're going to make a new method called add. Okay, so let's review what we've done here. So we created a new method called add, and it takes two arguments, test1 and test2. And when it calls this function, it will add up the two values into a result, and it will return that result. Once we've created the function, we need to add in our main function a way to call that. So we're going to add an operation, add. We're going to parse the arguments of the array for the first and second elements, and we're going to pass that into our add function. So let's go ahead and compile that. And as you can see here, it compiled successfully, and we now have our add function with the arguments test1 and test2. So we can go back to run and select our new add function. We can select the input argument of type integer, and let's just clear out our console logs here, and let's just add 1 and 2 and hit debug run. And here on the left hand side it says invoke integer 3. So this means that it successfully invoked this smart contract for the method add, and as you can see here, we returned a result which is 3. And so you can return different data types, which we'll go over in a later tutorial, but you can see here that it successfully completed. Alright, so thanks for watching this walkthrough tutorial. If you want any more information about how to build smart contracts or how to build applications on the Ontology blockchain, you can head over to learn.towerbuilders.org and you can go through any of the tutorials in this series.